Hey everyone, let's derive the sum and difference formula for the cosine function. And these are the two identities that we are going to derive using this unit circle. In the unit circle O, the radius is given to be 1 unit. And so the coordinate now of this point, let's call this point as point B, is 1, 0, where the x coordinate is 1 unit and the y coordinate is 0. Now let's draw an angle with its vertex at the center of circle O. And let's label the angle as angle POQ. Now from ray OB, the angle that is formed here is alpha. So that means angle POB is alpha. And let the measure of angle QOB to be beta. That means if the measure of angle POB is alpha, then the coordinate of point P is cosine alpha, sine alpha. And if the measure of angle QOB is beta, then the coordinate of point Q is cosine beta, sine beta. Now, let's draw another angle by rotating angle POQ. In other words, we just push this angle this way, and we also push this angle going this way. This implies that these two angles are equal. So let's label our angle first. Let's call our angle as angle AOB. And if the measure of this acute angle here is beta, this angle here is also beta because these two angles are congruent. Now, if the measure of angle POB is alpha, and the measure of angle AOP is beta, then the measure of angle AOB, this angle, must be equal to alpha minus beta, because we just subtracted this angle beta. And by knowing that the measure of angle AOB to be alpha minus beta, then we can now identify what is the coordinate of point A. The coordinate of point A is the ordered pair. The x-coordinate is cosine alpha minus beta, and the y-coordinate is sine alpha minus beta. Now, let's connect point P to point Q in order to form triangle POQ. And let's connect also point A to point B in order to form triangle AOB. Now, these two triangles are congruent because the pink triangle is just formed by rotating the blue triangle B angles clockwise direction. And therefore, we can now say that the distance PQ, which is the hypotenuse of the blue triangle, is equal to the distance AB, which is also the hypotenuse of the pink triangle. With this as our geometric construction, we are now ready to derive the difference identity for the cosine function. Let's do that. Using the distance formula, let's find first the distance PQ. So we want the distance from point P, which is this point, up to point Q, which is this point. In order to do that, let's recall the distance formula. The distance formula is given by this formula. The distance D is equal to the square root of the square of the difference between x sub 1 and x sub 2 plus the square of the difference between y sub 1 and y sub 2. Since we are getting the distance between point P and point Q, our x sub 1 is the x-coordinate of point P, which is cosine alpha, and our x sub 2 is the x-coordinate of point Q, which is cosine beta. For y sub 1 and y sub 2, the y-coordinate of point P is sine alpha, and the y-coordinate of point Q is sine beta. So using now those values to substitute in our formula, we now arrive at this. The distance PQ is equal to the square root of cosine alpha, which is our x sub 1, minus cosine beta, which is our x sub 2, all raised to the second power, minus our y sub 1 is sine alpha, minus y sub 2 is our sine beta, all raised to the second power. Notice here that we have a square of a binomial, so we can expand this by getting the square of the first term minus twice the product of the first and the second term plus the square of the second term. So the expansion of this square of binomial is this blue part. Then let's square also this other binomial. We square the first term minus twice the product of the first and the second term plus the square of the second term. So the square of this yellow binomial is this yellow part. Then from these results, notice that you have cosine squared alpha here, and you have here sine squared alpha. And we know from trigonometric identity that cosine squared of an angle plus sine squared of the same angle is equal to 1. We also have here cosine squared beta and sine squared beta, which is also equal to 1. So let's group together all those values that are equal to 1. So this part here is equal to 1, and this part here also is equal to 1. So simplifying, the sum of cosine squared alpha plus sine squared alpha is equal to 1. We copy minus 2 cosine alpha cosine beta. The sum of cosine squared beta plus sine squared beta is equal to 1. And we copy minus 2 sine alpha sine beta. And then 1 plus 1 gives us 2, and therefore we arrive at the square root of 2 minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta for the distance between point P and point Q. Now, we are going back to this value later on, so we need to remember this formula. After getting an expression for the value of the distance between P and Q, let's also get an expression representing the distance between point A and point B. Using distance formula again to find the distance between points A and B, we know that the coordinate of point A is cosine alpha minus beta, sine alpha minus beta, and the coordinate of point B is 1, 0. We are going to use this x coordinate as x of 1, this is our x sub 2, this will be our y sub 1, and this will be our y sub 2. So substituting now these values to our formula, we now arrive at this line, where our x sub 1 is cosine of alpha minus beta, x sub 2 is 1, y sub 1 is sine alpha minus beta, and y sub 2 is 0. And those are the x and y coordinates of points A and point B. Again, we have here a square of a binomial, so let's simplify this. So this part here is simplified as the square of the first term minus twice the product of the first and the second term plus the square of the last term. And then for the second part, the square of the first term is this minus 2 times this expression times 0, which is also 0, plus the square of the last term, which is 0 squared, which again is 0. So what we have here is just this yellow part. Notice here also that you have the cosine squared of an angle plus the sine squared of the same angle, which is equal to 1 using our Pythagorean identity. And therefore, we can simplify this further as 1 minus copy 2 cosine alpha minus beta plus 1, because this part here is just equal to 1 using Pythagorean identity. And then you have here a constant 1 and another constant 1. So we can combine these two constants to arrive at the distance between points A and B equals the square root of 2 minus 2 cosine alpha minus beta. At this point, we have an expression for the distance between points P and Q, and we also have this expression for the distance between points A and B. And geometrically, we said that the distance PQ is equal to the distance AB. So whatever expression we arrive at for the distance AB and the distance PQ, we can equate the two. So we now have this formula for distance between points P and Q. We have this formula for the distance between points A and B. We know that these two distances are equal, and so we now arrive at this equation. The distance between P and Q and the distance between points A and B are equal. Now we square both sides to eliminate the radical symbol, and we notice that you have here 2 and another 2 which we can cancel out, And so we now arrive at this last line. We can also factor out this common factor of 2, and dividing both sides by -2, we now arrive at cosine alpha cosine beta plus sine alpha sine beta is equal to cosine alpha minus beta, which is now our difference identity for the cosine function. So the difference identity now for the cosine function is given by this formula, the product of cosine alpha cosine beta plus the product of sine alpha sine beta. This is for the difference formula. Now we want also to find what is the sum formula for the cosine function. For the sum formula, since you already know the formula for the cosine of alpha minus an angle, what we're going to do is we're just going to perform some algebraic trick. Subtraction is defined as adding the additive inverse. So if you write alpha minus negative beta, this is just the same as alpha plus the additive inverse of negative beta, which is positive beta. So you will arrive at alpha plus beta. But when we rewrite cosine alpha plus beta in difference form, we'll be able to apply the results that we already derived previously. So using now these results that we arrived for the difference identity of cosine function, we now find the equivalent identity for cosine of alpha minus negative beta. So just substituting negative beta for beta, we now arrive at this right part of this equation. And since cosine is an even function, the cosine of negative beta is just the same as the cosine of positive beta. And since sine is an odd function, the sine of negative beta is equal to negative sine beta. So simplifying cosine of negative beta, we arrive at cosine beta. Simplifying sine of negative beta, we arrive at negative sine beta. Then multiplying sine alpha times negative sine beta, we arrive at negative sine alpha sine beta. We just copy cosine alpha cosine beta. Notice now that this is the formula for the sum identity of the cosine function. So at this point, we now have these two formula. One for the difference, the other is for the sum of the two angles. And so we are able now to prove the sum and difference formula for the cosine function. We'll see you in our next video.